All right, 7.1, level 1 is just evaluating basic trig ratios. So we did this last year. If you remember, the phrase that we used was SOHCAHTOA. So if you want to write this at the top of your paper, that might help you. Okay, so SOHCAHTOA. So what that means is, we look down at this box here. The sign, it's spelled S-I-N-E. We use the abbreviation S-I-N. Okay, that's sine, not sin. And then cosine is C-O-S. And we say cosine, but we abbreviate it with C-O-S. And then tangent, we abbreviate it using T-A-N. Okay, so how we find sine is what the so part is. The so out of the SOHCAHTOA. So it's opposite over adjacent. I'm sorry, not adjacent. Hypotenuse. Okay, and I'll go over how we find what the sides are in 1 second. Cosine then is the ca part, and that's going to be adjacent over hypotenuse. And then tangent is the TOA, so and that's opposite over adjacent. All right, so that's what we learned last year. It depends what angle you're coming from in the triangle. So if we take a look at this triangle up top, if we are coming from angle C, so if it asks you to find the sine of angle C, I always put my pencil or stylus on C and I draw a line to the right angle. That's how I would find the adjacent side. And then always the hypotenuse is always going to be across from the right angle, and then the other side is going to be the opposite. Okay, but if I'm coming from, say, angle A, and I draw a line from the right to the right angle, that side is now the adjacent side. The hypotenuse is still the hypotenuse, but now the other side is the opposite. So it depends what side you're coming from to determine what's your opposite and what's your adjacent side. So always just put your pencil on the angle that it's talking about and draw a line to that right angle, and that's going to be your adjacent side. Okay. So we've got 3 new functions to talk about this year. They're cosecant, secant, and cotangent. Cosecant, we use the abbreviation CSC, and that definition, we're going to take the hypotenuse over the opposite side. If you see, you can notice that that's the reciprocal of sine. Notice sine was the opposite over the hypotenuse, and cosecant is going to be the hypotenuse over the opposite. So that's a reciprocal of, just what I said, a sine. Okay, next one is secant. We abbreviate this using SEC, and this is going to be the hypotenuse over the adjacent side. And this is the reciprocal of cosine. And last but not least, we've got cotangent. Cotangent we abbreviate using COT. And this is going to be the opposite of tangent. So tangent was opposite over adjacent. This is going to be adjacent over the opposite. So like I said, this is the reciprocal of tangent. Okay, so if you can remember the SOHCAHTOA and then remember what order the reciprocal functions go in, then it's just the opposite of SOHCAHTOA in terms of adjacent over hypotenuse or hypotenuse over adjacent. Okay, all right, so let's go ahead and do some practice here. It says find all 6 trig ratios for the angle A. So I'm going to go ahead and write SOHCAHTOA here so I can remember this. Okay, so from angle A, so again, I'm going to use my trick to label my sides. So from angle A, I'm going to draw a line to the right angle. That's my adjacent side. My hypotenuse is always a hypotenuse. And the last one is the opposite side. So I noticed that I'm missing that opposite side. That's because we got to find it. So in a right triangle, we've got two sides. We can find the third side using the Pythagorean theorem. So I'm going to take 5 squared plus b squared equals 13 squared. And I'm just going to continue solving for b. So I got b to equal 12. Okay, so that third side is going to be 12. So now I can go ahead and fill in my ratios. So sine of A, so from A, sine is opposite over hypotenuse. So the opposite side of angle A we labeled was 12, and the hypotenuse is 13. And cosine from angle A, cosine is adjacent over hypotenuse, and the adjacent side we labeled as 5, and the hypotenuse we labeled as 13. Tangent we labeled is opposite over adjacent, and opposite was 12, and adjacent was 5. Okay, so now we're getting to those reciprocal identities, cosecant, secant, and cotangent. You can do one of two things. You can, if you remember that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, you can just flip what you got from the answers above, or you can reverse the SOHCAHTOA. So you can say cosecant is hypotenuse over adjacent. Secant is hypotenuse over adjacent. Whoops, I meant cosecant is the hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over hypotenuse. So you can flip that, or you can always just find like the main identities that you learned last year and just take the reciprocal of it. So cosecant, the first one is the reciprocal of sine, so it's going to be the hypotenuse over opposite, so 13 over 12. Secant is going to be hypotenuse over adjacent, so 13 over 5. And cotangent is going to be the adjacent over the hypotenuse, which is 5 over 12. Okay? All right. So now in number 2, it says determine the trig ratio that will make the equation true. So this is saying from angle L, the ratio 24 over 5, what trig function is that? So if I put my pencil on L and I draw a line to the right angle, the 24 is going to be the adjacent, which will make the 25 the hypotenuse. So I'm saying what trig function is the adjacent over hypotenuse? And that's going to be cosine. Okay, I'm going to try this again. For the second one, it says from angle M, what function gives me 24 over 5? So from angle M, I'm going to draw a line to the right angle. That's my adjacent. The other side is the opposite, and 25 is the hypotenuse. So which one is going to be O over H? That's going to be sine. And then last but not least, we have from angle M, again. Okay, I'm just going to label these again because I erased them. We need to know 24 over 7, what's that going to give us? So that would be O over A. So 24 is the opposite, the 7 is the adjacent, and that's going to be tangent.